Hello, in this lecture we will find out the value of angle ADC using two different methods. In the drawing we have triangle ABC. We know that angle ABC, this angle equals to 30 degrees. Angle ACD, this angle equals to 100 degrees. And we also know that side AD equals to side BC. And we want to find out the value of this angle, angle ADC. So we'll start with the first method. In the first method, we will define side AC of triangle ABC as point A, that is to say, the length of side AC is equal to A units, and we will define side BC of triangle ABC as B, that is to say, side BC equals to B units in its length, and I will present to you a new law that is actually the law of sines. But before that, we know that AD equals to BC, and according to our definition, BC equals to B. Therefore, from this equation that AD equals to BC equals to B, we will derive that AD also equals to B. And now I present to you a new law that is the law of sines. The law of sines is true in any triangle. So I write down that in any triangle, so if we have triangle ABC, that would be any triangle, triangle ABC. This is triangle ABC. And we know that the length of side BC is equal to A units. And this is angle A. The length of side AC equals to B units. This is angle B. And the length of side AB equals to C units. And this is angle C. Then, according to the law of sines, A over sinus A equals to B over sinus B equals to C over sinus C. I'll repeat again, in any triangle, A over sinus A equals to B over sinus B equals to C over sinus C. From this formula we will derive that A over sinus A equals to b over sinus b. And we will implement the law of sines in our triangle ABC. So I will copy triangle ABC in a new page, and we will implement the law of sines in this triangle ABC. So this is triangle ABC that I copied from the original drawing. We will find out the value of this angle BAC, so we define it as angle X. We know that the sum of the angles in any triangle is equal to 180 degrees, so angle X plus 30 degrees plus 100 degrees must be equal to 180 degrees. We will subtract 120 degrees from this equation, and we will get that angle X equals to 180 degrees minus 130 degrees is 50 degrees. So we found out that this angle X equals to 50 degrees. So I substitute angle X by 50 degrees. So angle BAC equals to 50 degrees. Now we will implement the law of sines in this triangle, triangle ABC. According to the law of sines, we will get that A over sinus 30 degrees equals to B over sinus 50 degrees. So here we will divide equation number 1 by B, and then we will multiply it by sinus 30 degrees, and we will get that according to equation number 1, A over B equals to sinus 30 degrees over sinus 50 degrees. I repeat again, according to equation number 1, A over B equals to sinus 30 degrees over sinus 50 degrees. So in the next step, we will focus on triangle ADC, and we'll implement the law of sines in this triangle, triangle ADC. Okay, but first of all, we have already found out that angle BAC, this angle equals to 50 degrees. And if we define angle BAD, this angle is theta, then the value of angle DAC, the value of this angle, will be equal to 50 degrees minus theta. I repeat again, the value of angle DAC will be equal to 50 degrees minus theta. And then if we define angle ADC, the angle that we are looking for, as angle Y, then we know that the sum of the angles in any triangle is equal to 180 degrees. That is to say, angle Y plus angle, this angle is equals to 100 degrees, plus this angle that equals to 50 degrees minus theta must be equal to 180 degrees. So here we subtract 150 degrees from this equation, and we will get that angle Y minus theta equals to 180 degrees minus 150 degrees is 30 degrees. Here we will add theta to this equation, and we will get that the value of angle Y is equal to 30 degrees plus theta. So I found out that the angle that we are looking for, that is actually angle ADC, equals to 30 degrees plus theta. Now I will copy triangle ADC in a new page, and we will implement the law of sines in this triangle, triangle ADC. So actually this is triangle ADC that I copied from the original drawing. We know that AD equals to B units, AC equals to A units, angle DAC equals to 50 degrees minus theta, angle ADC, the angle that you are looking for, equals to 30 degrees plus theta, and angle ACD equals to 100 degrees. It is given us in the question. So we will implement the law of sines in this triangle, triangle ADC. According to the law of sines, we will get that A over sinus 30 degrees plus theta equals to B over sinus 100 degrees Here we will divide equation number 2 by B, and then we will multiply it by sinus 30 degrees plus theta, and we will get that according to equation number 2, A over B equals to sinus 30 degrees plus theta over sinus 100 degrees. This is according to equation number 2, but according to equation number 1, we have already found out that A over B equals to sinus 30 degrees over sinus 50 degrees. So we actually have two different expressions for A over B. Therefore, we will create equation number 3 that states that A over B, according to equation number 1, must be equal to A over B according to equation number 2. Okay? And A over B according to equation number 1, it is actually equals to sinus 30 degrees over sinus 50 degrees. And it must be equal to A over B according to equation number 2. That is actually A over B according to equation number 2 is sinus 30 degrees plus theta over sinus 100 degrees. So I repeat again, according to equation number 3, A over B according to equation number 1 equals to A over B according to equation number 2. Here we will cross multiply equation number 3, and we will get that according to equation number 3, first of all we know that sinus 30 degrees is 1 over 2. Times sinus 100 degrees equals to sinus 30 degrees plus theta times sinus 50 degrees. Here we will use the trigonometric identity that states that sinus 2a equals to 2 sinus a cosine a. According to this trigonometric identity, we will get that sinus 100 degrees equals to 2 sinus 50 degrees times cosinus 50 degrees, and it equals to sinus 30 degrees plus theta times sinus 50 degrees. So here 2 over 2 is 1, so 2 will get cancelled. We have sinus 50 degrees on both sides of equation number 3, so sinus 50 degrees will also get cancelled. And we're left only with cosine 50 degrees that equals to sine 30 degrees plus alpha plus theta. I'll repeat again, cosine 50 degrees, according to equation number 3, cosine 50 degrees equals to sine 30 degrees plus alpha. Here we will use the trigonometric identity that states that cosine alpha equals to sine 90 degrees minus alpha. So according to this trigonometric identity, we will get that cosine 50 degrees equals to sine 90 degrees minus 50 degrees. That is to say, cosine 50 degrees equals to sine 90 degrees minus 50 degrees is 40 degrees, so it equals to sine 40 degrees. So we found out that cosine 50 degrees equals to sine 40 degrees. Therefore, we can substitute cosine 50 degrees in this equation, equation number 3, by sine 40 degrees. And we will get that according to equation number 3, sine 40 degrees equals to sine 30 degrees plus theta. Sine 40 degrees that equals to sine 30 degrees plus theta means that 40 degrees equals to 30 degrees plus theta. Here we'll subtract 30 degrees from this equation, equation number 3, and we will get that according to equation number 3, angle theta equals to 40 degrees minus 30 degrees is 10 degrees. So angle theta, we found out that angle theta equals to 10 degrees. Here angle theta equals to 10 degrees. Also here angle theta equals to 10 degrees. But the angle that we are looking for is angle ADC that equals to 30 degrees plus theta. Therefore 30 degrees plus theta, it is actually 30 degrees plus 10 degrees that equals to 40 degrees. So actually we found out that the angle that we are looking for, that is actually angle ADC, equals to 30 degrees plus theta, that is to say it equals to 40 degrees. Okay? The angle that we are looking for equals angle ADC equals to 40 degrees. We finished with the first method. In the next step, I will present to you how to find out the value of this angle, angle ADC, according to the second method. Okay. So in the second method, we will define side BC of triangle ABC as A. That is to say, the length of side BC equals to A units, and then we will extend side BC by a straight line. And from point A, we will draw perpendicular to the extended BC. That is to say, this angle will be equal to 90 degrees, and this angle will be also equal to 90 degrees. And we will define the intersection point between the perpendicular from point A and the extended BC as point E. And we will find out the value of angle ACE, this angle. We actually know that BC is one side of triangle ABC, therefore it is absolutely a straight line. And when we extended the straight line BC by a straight line, we got line segment BE that is still must be a straight line. So we know that line segment BE is a straight line, so I write it down. Line segment BE is a straight line. And we actually have a rule that the sum of the angles on one side of a straight line is equal to 180 degrees. So if we focus on the upper side of the straight line BE at point C, according to the rule that I mentioned, the sum of the angles on the upper side of the straight line BE at point C must be equal to 180 degrees. So if we define angle ACE, this angle as angle Y, then we will get that 100 degrees plus the size of angle Y must be equal to 180 degrees according to the rule that I mentioned. So here we will subtract 100 degrees from this equation, and we will get that angle Y equals to 180 degrees minus 100 degrees, it equals to 80 degrees. So we found out that angle Y equals to 80 degrees. So we will change the value of angle Y to 80 degrees. In the next step, we will define side AE as Y. That is to say, the length of side AE equals to Y units. And we will define side CE as X. That is to say, the length of side CE or line segment CE equals to X units. And we will focus on the right triangle, triangle ACE. On this right triangle, triangle ACE. On the right triangle, triangle ACE, we know that triangles 80 degrees. equals to AE over CE. I'll repeat again. On the right triangle, triangle ACE, triangle 80 degrees equals to AE over CE. But according to our definition, AE equals to Y and CE equals to X. So in conclusion, we will get that according to equation number 1, tangents 80 degrees equals to Y over X. I repeat again, according to equation number 1, tangents 80 degrees equals to Y over X. Here we will multiply equation number 1 by X, and we will get that Y, according to equation number 1, Y equals to X times tangents 80 degrees. Okay. In the next step, we will focus on the right triangle, triangle ADE. But first of all, we will define angle ADE. Actually, the angle that we are looking for is angle theta. And the value of sinus theta in equation, if we focus on triangle ADE, the value of sinus theta will be equal to AE over AD. I'll repeat again. On the right triangle, triangle ADE, the value of sinus theta will be equal to AE over AD. But according to our definition, AE equals to Y. And we have already found out that AD equals to, according, we know that AD equals to BC, AD equals to BC, according to what is given us in the question, but according to our definition, BC equals to A. So we have the equation that AD equals to BC equals to A. From this equation we will derive that AD also equals to A. So actually AD equals to A. So we can substitute AD by A. AD equals to A. So in conclusion, we found out that according to equation number 2, sinus theta equals to Y over A. I'll repeat again. According to equation number 2, if we focus on triangle ADE, we will get that sinus theta equals to Y over A. Here we will multiply equation number 2 by A, and then we will divide it by sinus theta, and we get that the value of A, according to equation number 2, is equal to y over sinus theta. But according to equation number 1, y equals to x times 80 degrees, so we substitute the value of y in equation number 2 by x times 80 degrees, and we will get that, in conclusion, we will get that A equals to y, that is x times 80 degrees, over sinus theta. And according to equation number 1, y equals to x times 80 degrees. In the next step, we will focus on the right triangle, triangle ABE. On the right triangle, triangle ABE, tangent 30 degrees, equals to AE over BE. I will repeat again. In the right triangle, triangle ABE, tangent 30 degrees equals to AE over BE. But AE equals to y according to our definition, and BE equals to A plus X. So in conclusion, according to equation number 3, we will get that tangent 30 degrees equals to y over A plus X. I repeat again. According to equation number 3, tangent 30 degrees equals to y over A plus X. So we know that y equals to x times 80 degrees, so we'll substitute y by x times 80 degrees, and according to equation number 2, A equals to x times 80 degrees over sinus theta, so we'll substitute A in equation number 3 by x times 80 degrees over sinus theta. And we will get that tangent 30 degrees equals to y, according to equation number 1, y equals to x times tangent 80 degrees over A plus X. A, according to equation number 2, equals to x times tangent 80 degrees over sinus theta. And we also have to add x. So here we'll multiply x by sinus theta, and then we will divide it by sinus theta, so we change nothing. Here we will move sinus theta from the denominator to the numerator, and we will get that, according to equation number 3, tangent 30 degrees equals to x times tangent 80 degrees times sinus theta over x times tangent 80 degrees plus x times sinus theta Here we have x in the numerator and we have x in the denominator, so x will get cancelled. And we know that tan 30 degrees equals to 1 over square root of 3 units. So we'll substitute tan 30 degrees in equation number 3 by 1 over square root of 3 units, and we will get that according to equation number 3, one over square root of 3 units equals to tan 80 degrees times sinus theta over tan 80 degrees plus sinus theta So according to equation number 3, 1 over square root of 3 units equals to tan 80 degrees times sinus theta over tan 80 degrees plus sinus theta. Here we will cross multiply this equation, equation number 3, we will get that according to equation number 3, tan 80 degrees plus sinus theta equals to square root of 3 times tan 80 degrees times sinus theta. Here we will subtract sinus theta from this equation, equation number 3, and we will get that according to equation number 3, tan 80 degrees equals to square root of 3 times tan 80 degrees times sinus theta minus sinus theta. So here we'll take sinus theta as a common factor on this side of equation number 3, and we will get that tan 80 degrees equals to sinus theta was taken as a common factor. So inside the brackets, what is left from this expression after we took from it sinus theta, what is left? It is actually square root of 3 times tan 80 degrees, and we will take a common factor from minus sinus theta. What is left from minus sinus theta after we took from it sinus theta as a common factor? What is left? It is actually minus 1. Here we will divide equation number 3 by square root of 3 times tan square root of 3 times sinus theta minus 1. And we get that according to equation number 3, sinus theta equals to tangent 80 degrees over square root of 3 times tangent theta minus 1. Here we will substitute tangent 80 degrees by sinus 80 degrees over cosine 80 degrees, and we will get that sinus theta according to equation number 3 will be equal to tangent 80 degrees is sinus 80 degrees over cosine 80 degrees. And here it is actually tangent 80 degrees. Tangent 80 degrees. So we have square root of 3 times tangent 80 degrees, and tangent 80 degrees is sinus 80 degrees over cosine 80 degrees. And we have also to subtract minus 1, so we'll substitute minus 1 by minus cosine 80 degrees over cosine 80 degrees. Minus cosine 80 degrees over cosine 80 degrees equals to 1, of course. Here we have cosine 80 degrees in the numerator, and we have cosine 80 degrees in the denominator, so cosine 80 degrees will get cancelled. What is left from equation number 3 after we cancelled cosine 80 degrees from it? What is left is actually in this side of the equation we have sinus theta that equals to sinus 80 degrees over square root of 3 times sinus 80 degrees minus cosine 80 degrees Here we'll multiply the denominator in this side of equation number 3 by 2, and then we'll divide it by 2, and we'll get that sinus theta equals to sinus 80 degrees again. I repeat again that we will multiply the denominator by 2, so it will be 2 times square root of 3 times sinus theta times sinus 80 degrees minus cosine 80 degrees, and then we will divide it by 2, so here we will have square root of 3 times sinus 80 degrees over 2, and then here we will have also cosine 80 degrees over 2. So we get that according to equation number 3, sinus theta equals to sinus 80 degrees over 2 times sinus 80 degrees. Here we substitute square root of 3 over 2 by cosine 30 degrees, because cosine 30 degrees equals to square root of 3 over 2 minus, we substitute 1 over 2 by sinus 30 degrees times cosine 80 degrees. So we got that according to equation number 3, sinus theta equals to sinus 80 degrees over 2. Here sinus 80 degrees times cosine 30 degrees minus 30 degrees times cosine 80 degrees is very similar to the trigonometric identity that states that sinus A cosinus B minus sinus B cosinus A equals to sinus A minus B. So according to this trigonometric identity, we can substitute our expression by sinus A minus B when A equals to 80 degrees and B equals to 30 degrees. So we'll do it now and we'll get that our expression, that is to say sinus 80 degrees times cosine 30 degrees minus sinus 30 degrees times cosine 80 degrees equals to sinus A minus B when A equals to 80 degrees and B equals to 30 degrees. So in conclusion, our expression equals to sinus 80 degrees minus 30 degrees. So according to equation number 3, we will get that sinus theta equals to sinus 80 degrees over 2 times 80 degrees minus 30 degrees is 50 degrees, so it is actually 2 times sinus 50 degrees. We'll use the trigonometric identity that states that sinus alpha equals to cosine 90 degrees minus alpha. According to this trigonometric identity, we will get that sinus 50 degrees equals to cosinus 90 degrees minus 50 degrees. 90 degrees minus 50 degrees is 40 degrees, so we got that sinus 50 degrees equals to cosine 40 degrees. Okay, we found out that sinus 50 degrees equals to cosine 40 degrees. Therefore, we can substitute sinus 50 degrees in this equation by cosine 50 degrees. So we'll do it now and we will get that according to equation number 3, sinus theta equals to sinus 80 degrees over 2 times, I repeat again, we will substitute sinus 50 degrees by cosine 40 degrees. So actually, in conclusion, we found out that according to question number 3, sinus theta equals to sinus 80 degrees over 2 times cosinus 40 degrees. Here we use the trigonometric identity that states that sinus 2a equals to 2 sinus a cosinus a. So according to this trigonometric identity, the value of sinus 80 degrees will be equal to 2 sinus 40 degrees times cosinus 40 degrees, all divided by 2 times cosine 40 degrees. Here we have 2 over 2 is 1, so 2 will get cancelled. We have cosine 40 degrees over cosine 40 degrees is 1, so cosine 40 degrees will also get cancelled, and we left only with sine theta that equals to sine 40 degrees. Sine theta equals to sine 40 degrees means that theta equals to 40 degrees. So we found out that this angle theta, equals to 40 degrees. And actually the angle that we are looking for, that is actually angle ADC equals to 40 degrees. So angle ADC, the angle that we are looking for, is equal to angle theta that equals to 40 degrees. So angle ADC equals to 40 degrees in both methods. Now I will summarize the lecture. Actually, we wanted to find out the value of this angle ADC. We found the value of angle ADC in 2 different methods. In the first method, we defined side AC of triangle ABC as A and side BC of triangle ABC as B. According to what is given us in the question, AD equals to BC, but according to our definition, BC equals to B. So from this equation, AD equals to BC equals to B, we will derive that AD also equals to B. Okay, AD equals to B. Then I presented to you the law of sines. The law of sines is true in any triangle. If we have triangle ABC, this triangle that could be any triangle, we know that side AB equals to C units in its length, side AC equals to B units in its length, and side BC equals to A units in its length. Then according to the law of sines, A over sine A equals to B over sine B equals to C over sine C, and it is true in any triangle. Okay, so from this formula we will derive that A over sine A equals to B over sine B. Then we implemented the law of sines in triangle ABC. In triangle ABC, we know that angle ACD equals to 100 degrees, angle ABC equals to 30 degrees, and we also know that the sum of the angles in any triangle is equal to 180 degrees. So if we define the missing angle, angle CAB as x, we will get that x plus 100 degrees plus 30 degrees must be equal to 180 degrees. Here we subtracted 130 degrees from this equation, and we found out that the value of angle x, this angle CAB, equals to 50 degrees. In the next step, we implemented the law of sines in this triangle ABC. According to the law of sines, A over sinus 30 degrees equals to B over sinus 50 degrees. Okay, so here we will divide equation number 1 by B, and then we multiply it by sinus 30 degrees, and we found out that A over B, according to equation number 1, equals to sinus 30 degrees over sinus 50 degrees. Then we actually implemented the law of sines in triangle ADC also. But first of all, we have already found out that this angle, angle BAC, equals to 50 degrees. So if we define angle BAD as theta, then the value of this angle, angle DAC, will be equal to 50 degrees minus theta. So we found out that the value of angle DAC equals to 50 degrees minus theta. So I copied this triangle ADC in a new page. But before that, we found out the value of this angle. We defined this angle, angle ADC, the angle that we are looking for is y. And we know that the sum of the angles in any triangle is equal to 180 degrees. That is to say, angle y plus 100 degrees plus this angle that is 50 degrees minus theta must be equal to 180 degrees. Here we subtracted 150 degrees from this equation. When we got that y minus theta equals to 180 degrees minus 150 degrees is 30 degrees. Here we added theta to this equation, and we found out that angle y equals to 30 degrees plus theta. This angle y equals to 30 degrees plus theta. So I copied this triangle ADC in the new page, and we implemented the law of sines in this triangle ADC. This is triangle ADC that I copied to this page from the original drawing. We know that AD equals to B units, AC equals to A units, angle DAC equals to 50 degrees minus theta, angle ACD equals to 100 degrees, and angle ADC equals to 30 degrees plus theta. So we implemented the law of sines in this triangle ADC according to the law of sines. A over sinus 30 degrees plus theta equals to B over sinus 100 degrees. Here we divided the equation number 2 by B, and then we multiplied by sinus 30 degrees plus theta, and we got that A over B, according to equation number 2, equals to sinus 30 degrees plus theta over sinus 100 degrees. But according to equation number 1, A over B equals to sinus 30 degrees over sinus 50 degrees. So we have two different expressions for A over B. Therefore, we created equation number 3 that states that A over B according to equation number 1 must be equal to A over B according to equation number 2. Okay, and A over B according to equation number 1 equals to sinus 40 degrees over sinus 50 degrees, and it must be equal to A over B according to equation number 2 that equals to sinus 30 degrees plus theta over sinus 100 degrees. Here we cross multiply this equation number 3, and we know that sinus 30 degrees is 1 over 2, so we got that 1 over 2 times sinus 100 degrees equals to sinus 30 degrees plus theta times sinus 50 degrees. Here we use the trigonometric identity that sinus 2a equals to 2 sine a cosine a in order to find the value of sinus 100 degrees. According to this trigonometric identity, we will get that sinus 100 degrees equals to sinus 50 degrees times cosine 50 degrees, and it equals to sinus 30 degrees plus theta times sinus 50 degrees. Here 2 over 2 is 1, so 2 will get cancelled, and we have sinus 50 degrees on both sides of equation number 3, so sinus 50 degrees will be also get cancelled, and we left only with cosine 50 degrees that equals to sine 30 degrees plus theta. Then use the trigonometric identity that cosine alpha equals to sine 90 degrees minus alpha. According to this trigonometric identity, we will get that the value of cosine 50 degrees will be equal to sine 90 degrees minus 50 degrees. 90 degrees minus 50 degrees is 40 degrees, so in conclusion we found out that the value of cosine 50 degrees according to this trigonometric identity is equal to sinus 40 degrees. Therefore, we can substitute cosine 50 degrees in this equation number 3, by sine 40 degrees because they are equal to each other. We did it, and we found out that sine 40 degrees equals to sine 30 degrees plus theta. Sine 40 degrees equals to sine 30 degrees plus theta means that 40 degrees equals to 30 degrees plus theta. Here we subtracted 30 degrees from this equation number 3, and we found out that the value of angle theta is 10 degrees. The value of this angle theta is 10 degrees, and here also theta equals to 10 degrees, but the angle that we are looking for, it is actually angle ADC that equals to 30 degrees plus theta. Therefore, the value of angle ADC that equals to 30 degrees plus theta will be equal to 30 degrees plus theta, that is 10 degrees. That is to say, the value of angle ADC is equal to 40 degrees. We finish with the first method. In the next step, I present to you how we found out the value of angle ADC according to the second method. In the second method, we defined side BC by A, that is to say the length of side BC equals to A according to our definition. And we know it is given us in the question that AD equals to BC, AD equals to BC. But according to our definition, AD equals to A. So from this equation that AD equals to BC equals to A, we will derive that AD also equals to A. Here AD equals to A. Then I extended side BC by a straight line, and from point A we drew perpendicular to the extended BC. Therefore this angle equals to 90 degrees, and this angle also equals to 90 degrees. And we defined the intersection point between the perpendicular from point A and the extended BC as point E. Then we found out that the value of this angle, angle ACE. We know that BC is a straight line because it is one side of triangle ABC, therefore it is absolutely a straight line. And after we extended the straight line BC by a straight line, we got line segment BE that is still must be a straight line. So we know that line segment BE is a straight line, and according to the rule that the sum of the angles on one side of a straight line is equal to 180 degrees, so if we focus on the upper side of the straight line BE at point C, then the sum of its angles must be equal to 180 degrees, that is to say 100 degrees plus this angle, that is angle Y, must be equal to 180 degrees. On the straight line BE, the sum of the angles must be equal to 180 degrees, that is to say 100 degrees plus angle Y must be equal to 180 degrees. We subtracted 100 degrees from this equation and found out that angle Y equals to 80 degrees. Angle Y equals to 80 degrees. Then we focus on the right triangle, triangle ACE. On the right triangle, triangle ACE, we know that triangle 80 degrees equals, but before that we define side AE as Y and side CE as X. And then in triangle ACE, you know that triangle 80 degrees equals to AE over CE. I'll repeat again, on the right triangle, triangle ACE, triangle 80 degrees equals to AE over CE. AE equals to Y and CE equals to X according to our definition. Therefore, in conclusion, we found out that triangle 80 degrees equals to Y over X. Here we multiply the equation number 1 by X, and we found out that Y equals to X times triangle 80 degrees. According to equation number 1, Y equals to X times triangle 80 degrees. Then we focus on the right triangle, triangle ADE. We defined angle ADE, the angle that we are looking for is angle theta. So in the right triangle, triangle ADE, we know that sinus theta equals to AE over AD. In the right triangle, triangle ADE, we know that sinus theta equals to AE over AD. But AE equals to Y, according to our definition, and we have already found out that AD equals to A. So in conclusion, we found out that sinus theta equals to Y over A. And here we multiplied equation number 2 by A, and then we divided by sinus theta, and we found out that A equals to Y over sinus theta, but Y equals to X times 80 degrees, so we substitute Y by X times 80 degrees, and we will get that A equals to X times 80 degrees over sinus theta, and according to equation number 1, Y equals to X times 80 degrees. Then we focus on the right triangle, triangle ABE. On the right triangle, triangle ABE, we know that triangle 30 degrees equals to AE over BE. In the right triangle, triangle ABE, we know that triangle 30 degrees equals to AE over BE. But AE equals to Y according to our definition, and BE equals to A plus X also according to our definition. So in conclusion, we found out that triangle 30 degrees equals to Y over A plus X. Then we know that Y equals to X times 80 degrees according to equation number 1, so we substitute Y by X times 80 degrees, and according to equation number 2, A equals to X times 80 degrees over sinus theta, so we substituted A by X times 80 degrees over sinus theta, and we got that triangle 30 degrees equals to X times triangle 80 degrees over X times triangle 80 degrees over sinus theta plus X, and we multiplied X by sinus theta, and then we divided by sinus theta, so we changed nothing. Here we moved sinus theta from the denominator to the numerator, and in conclusion we found out that triangle 30 degrees equals to X times triangle 80 degrees times sinus theta over X times 80 degrees plus X times sinus theta. Here we have X in the numerator and we have X in the denominator also. So x will get cancelled, and we know that tangens 30 degrees is equals to 1 over square root of 3 units, so we substituted tangens 30 degrees by 1 over square root of 3 units, and we got that according to equation number 3, 1 over square root of 3 equals to tangens 80 degrees times tangens theta over tangens 80 degrees plus sinus theta. Here we cross multiply this equation, equation number 3, and we got that tangens 80 degrees plus sinus theta equals to square root of 3 times tangens 80 degrees times sinus theta. Here we subtract the sinus theta from this equation, equation number 3, and we found out that according to equation number 3, tangens 80 degrees equals to square root of 3 times tangens 80 degrees times sinus theta minus sinus theta. Here we took sinus theta as a common factor from this side of equation number 3, and we found out that tangens 80 degrees equals to sinus theta, and inside the brackets we will have square root of 3 times tangens 80 degrees minus 1. Then we divided this equation, equation number 3, by square root of 3 times tangens 80 degrees minus 1, and we got that sinus theta equals to tangens 80 degrees over square root of 3 times tangens 80 degrees minus 1. Here we substituted tangens 80 degrees by sinus 80 degrees over cosine 80 degrees, and we got that according to equation number 3, sinus theta equals to tangens theta is sinus 80 degrees over cosine 80 degrees, and square root of 3 tangens theta, it is actually square root of 3 times sinus 80 degrees over cosine 80 degrees. And we also have to subtract 1. We substitute 1 by minus cosine 80 degrees over cosine 80 degrees, that equals to 1. So here we have cosine 80 degrees in the numerator, and we have cosine 80 degrees in the denominator. So cosine 80 degrees will get cancelled, and what is left after we cancelled cosine 80 degrees of my equation number 3, what is left is, in this side we have sinus theta that equals to sinus 80 degrees over square root of 3 times sinus 80 degrees minus cosine 80 degrees. So here we multiplied equation number 3, the denominator of equation number 3 by 2, and then we divided by 2. We got this expression. Here we multiplied by 2 and divided by 2. Here we multiplied by 2 and divided by 2. And then we substituted square root of 3 over 2 by cosine 30 degrees, and we substituted 1 over 2 by sine 30 degrees. So we got the expression that sinus theta equals to sinus 80 degrees over 2 times sinus 80 degrees times cosine 80 degrees. Sinus theta equals to sinus 80 degrees times 2 times sine 80 degrees times cosine 30 degrees minus sinus 30 degrees times cosine 80 degrees. And actually this expression, sinus 80 degrees times cosine 30 degrees minus sinus 30 degrees times cosine 80 degrees, is very similar to the trigonometric identity that states that sinus A cosine B minus sinus B cosine A equals to sinus A plus B, A minus B. So according to this trigonometric identity, we can substitute our expression by sine A minus B, when A equals to 80 degrees and B equals to 30 degrees. So we did it, and we got that sinus theta equals to sinus 80 degrees over 2 times sinus A minus B. A equals to 80 degrees and B equals to 30 degrees. Here 80 degrees minus 30 degrees is 50 degrees. So in conclusion, we found out that sinus theta equals to sinus 80 degrees over 2 times 50 degrees. Then we use the trigonometric identity that states that sinus alpha equals to cosine 90 degrees minus alpha. So according to this trigonometric identity, we will get that the value of sinus 50 degrees must be equal to cosine 90 degrees minus 50 degrees. 90 degrees minus 50 degrees is 40 degrees. So in conclusion, we found out that sinus 50 degrees equals to cosine 40 degrees. That is to say, we can substitute sinus 50 degrees in this equation, equation number 3, by cosine 40 degrees, because they are equal to each other. We did it, and we got that according to equation number 3, sinus theta equals to sinus 80 degrees over 2 cosine 40 degrees. Then use the trigonometric identity that sinus 2a equals to 2 sine a cosine a in order to find the value of sinus 80 degrees. According to this trigonometric identity, we will get that the value of sine 80 degrees is 2 sine 40 degrees times cosine 40 degrees. So in conclusion, we found out that according to equation number 3, sinus theta equals to 2 sine 40 degrees times cosine 40 degrees over cosine 40 degrees. Here 2 over 2 will get, 2 over 2 is 1, so 2 will get cancelled. We have cosine 40 degrees in the numerator and cosine 40 degrees in the denominator, so cosine 40 degrees will also get cancelled. And we left only with sine theta that equals to sine 40 degrees. Sine theta equals to sine 40 degrees means that theta equals to 40 degrees. So we found out here that theta equals to 40 degrees, but the angle that we are looking for is angle ADC that equals to theta. So angle ADC also equals to 40 degrees. So we found out in the second method that the angle that we are looking for, that is to say angle ADC equals to 40 degrees. So in both methods we found out that the angle that we are looking for, angle ADC, equals to 40 degrees. Okay, thank you very much.